differences of nth degree polynomial. Nth differences of polynomial of degree n will always be constant and its higher order differences will always be 0. Conversely, if nth difference of a function tabulated at equally spaced intervals is found to be constant, then you can conclude that the function will be a polynomial of degree n. Let's look at the proof of the result. Suppose f of x is the nth degree polynomial given by ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 plus etc. kx plus l, where a, b, c, etc. k, l are all constants. First difference of f of x obtained by delta f of x, which equals f of x plus h minus f of x, will be evaluated. We have f of x plus h, which is obtained by just replacing every x in the expression of f of x by x plus h. You will take the difference between f of x plus h and f of x to evaluate delta f of x, which is the first difference of nth degree polynomial. You will see that x plus h the whole raised to n has also the coefficient a, just like x raised to n has the coefficient a. Therefore, x plus h the whole raised to n minus x raised to n will have common coefficient a. Similarly, x plus h the whole raised to n minus 1 and x raised to n minus 1 share the common coefficient b. Hence, we have the term b times x plus h the whole raised to n minus 1 minus x raised to n minus 1. And so on, we have k multiplied to x plus h minus x. Forward difference operator applied on constant L will be 0. Here, when you apply binomial expansion, you have x plus h the whole raised to n equals x raised to n plus nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2 into h square plus etc. First term of the binomial expansion, x raised to n, and this negative x raised to n will get cancelled, and the highest power of x that will come out from this term evaluation will be x raised to n minus 1 along with its coefficients a and h. Similarly, here you will apply binomial expansion. The first term will be x raised to n minus 1, which get cancelled with this term. The next term will be a power of x raised to n minus 2, and that will be the highest power of x which will come out from this evaluation. And we will have b dash as an arbitrary constant appearing along with x raised to n minus 2. We are not interested in the exact expression of the constant coefficient that will appear along with x raised to n minus 2. We have just notated it as b dash. Similarly, from the next term evaluation, we will have x raised to n minus 3 as the highest power of x which will come out along with some arbitrary constant coefficients c dash, and so on. We have, after cancelling x and negative x, kh appears, and from this expression of first difference of nth degree polynomial, you notice that the polynomial of degree n minus 1 is obtained. That is, first difference of nth degree polynomial displays the output, which is a polynomial of degree n minus 1. Now we will evaluate second difference of nth degree polynomial, or delta square of f of x, which is obtained by application of forward difference operator in this expression. Replace every x in this expression by x plus h and you will get an expression. Then this entire expression should be subtracted from the expression which you obtained by replacing every x by x plus h. You notice that x plus h the whole raised to n minus 1 and x raised to n minus 1 have common coefficients a and h. Therefore, you have the first term a and h multiplied to x plus h the whole raised to n minus 1 minus x raised to n minus 1. Similarly, b dash will be the arbitrary constant appearing along with x plus h the whole raised to n minus 2 and x raised to n minus 2. Therefore, x plus h the whole raised to n minus 2 minus x raised to n minus 2 will have common coefficient b dash, and so on. Here you apply binomial expansion and you see that first term of the binomial expansion, x raised to n minus 1, get cancelled with this term negative x raised to n minus 1. The second term of binomial expansion will be x raised to n minus 2 into n minus 1 c1 into h. Therefore, we have x raised to n minus 2 as the highest power of x which will come out from this calculation, and we have x raised to n minus 2 has the coefficient a into n minus 1 into h square. Similarly, with the binomial expansion of this expression, x raised to n minus 2 and negative x raised to n minus 2 get cancelled. You will get x raised to n minus 3 as the highest power of x along with an arbitrary constant term b double dash. Next term will be x raised to n minus 4 from the next term evaluation along with an arbitrary constant c double dash. From this step, you notice that second difference of nth degree polynomial is a polynomial of degree n minus 2. Similarly, we have the third difference of nth degree polynomial will be a polynomial of degree n minus 3. Generalizing, we have nth difference of nth degree polynomial f of x will be of the form a into n minus 1 into n minus 2 into etc. into 1 into h raised to n. That is a into n factorial times h raised to n. That is nth difference of nth degree polynomial f of x will always be a polynomial of degree n minus n, which is 0. Polynomial of degree 0 will be a constant value. Thus, we have concluded nth difference of nth degree polynomial will always be a constant. Since forward difference operated on constant value will always be 0, n plus 1th difference of nth degree polynomial will be 0. Similarly, higher differences of nth degree polynomial will be evaluated as forward difference operator operated on 0, which will all be 0.